turn on, yeah?
Yeah.
Turn on the camera all the time, yeah? Okay, because I want to check the communications links as well, okay? Now the Tan, can you hear my voice clearly? Tan,
Yes, sir.
okay. Now, what are full words of MSB and RSB?
MS.
MSB,
So, can you repeat the question?
okay. What the full words of MSB and LSB?
MSB is most most significant bit, and LSB is least significant bit.
Yes.
Yes.
MSB is the most significant bit, and LSB is the least significant bit. In Vietnamese, we say, sorry, MSB is bit có trọng số cao nhất, LSB is bit có trọng số nhỏ nhất. Okay? Now, and R is the full scale range or reference. Okay. Now we look at directly, yeah, we view the table. Actually, this is, yeah, we put all of them into a table like this. So just stick into the table for sure. Okay, we see. If we want to work out for the values of the sample corresponding to the cost, okay, namely the SQ, we just apply this formula. R full scale, and we know the B1 to be B, then we can work out for the SQ. Unipolar, but bear in your mind, because this one is unipolar, natural binary. So that means we can convert only the values, positive value of samples only. Okay? Not apply to the negative value. But in the case of the negative value, yeah, you can put NA, non-applicable, or just round it to 0. It's still okay. Yeah? Otherwise, we put NA. How about the offset binary? Because the offset binary and two complements is bipolar, lưỡng cực. That means we have a half in negative part and a half specified for positive part of the full scale range. So that means we just take the value of the natural binary cost and convert it into SQ and shift it down a half of R. So we see this one. Yeah, actually we take the value in natural binary and minus 0.5 R. That means we shift it down. For example, in the case of the full scale range 10 volts, natural cost would apply to the value from 0 to nearly 10 volts. But the case of offset and choose complement will be processed from minus 5 volts to nearly 5 volts. Okay, what I say nearly 5 volts and nearly 10 volts because, yeah, we have to review, yeah, a specific Q of the maximum because we insert 0 quantization level. Okay, so what about the offset binary? The offset binary related to the complement, to the choose complement. Just we check complements of the most significant bits only. Okay, with the dash in here, we check the complements of B1. That one is the relationship between the offset and the choose complement cost. When you know the offset cost, very easy, you can convert to the choose complement quickly by taking the complements of the most significant bits. Okay? Now, did I talk to you about this table?
Yes, sir.
Already?
No.
No? Not yet. Okay. So, look at the table. This one show you the ways, we can convert the course. Look at here. Assume B is 4, R is 10 volts. What is the Q? What is the quantization resolution? And what is the quantization resolution? Bác Thành,
Mm, uh,
Viết,
I
what the
think it is
quantization resolution?
0.625.
Yeah, just take the R divided by 2 power of B. So
Yeah.
that means we take 10 volts divided by number of quantization level. 2 power of 4 is 16. 10 over 16 equal to 0.625. Okay, Q. Quantization width or quantization resolution. Okay, now look at this one. Now we build up the cost table like this. Okay, this one we say the cost table. Okay, now the first column, because B equal to 4. So we have a 4 bit, we just list 40 to 41. Okay, and then the second column just specify the decimal value of 4-bit code. And the third, now we start, because this one, for a natural binary, and this is the quantization level. Okay, then we start from 0. S1Q, 2Q, 3Q, and we go up until 9.375. Okay, we stop in here. We don't use 10 volts. 10 volts, we can route it to 9.375. Okay, that is the maximum value in the range. The system can be converted. Okay. So, and the first column, we write down for offset binary, because the offset binary is bipolar. So we start from -5 at 1Q and then go up to 4.375. Okay, this is the quantization level in the offset binary and choose complement. Okay, choose complement, because choose complement, we apply the bipolar code. So we use the same quantization level to the offset binary. What in Vietnamese we would say is two complements. Choose complement
Bù hai.
mã bù 2. Mã bù 2 chúng ta học trong máy tính số hoặc là học trong kỹ thuật số, chúng ta biết mã bù 2 chúng ta dùng để chúng ta thực hiện phép trừ. và specify for that is a negative value. Chúng ta dùng để chúng ta áp dụng cho các cái số âm. Negative value. Okay. So, for example, if we want to convert minus 1.25. Okay, we look at this one, minus 1.25. Go to the left-hand side. That is the offset binary code of minus 1.25. Okay. And straightforward, we can work out for the two complement by taking complements of the MSB. So that means corresponding to 1, 1, 1, 0. Or we can look at the right-hand side, 1, 1, 1, 0. And not applicable to the case of natural binary. Okay. Now, in the case if we want to convert 2.4, okay, 2.4 volts, 2.4 volts. Always the first step, we have to round it, or we have to quantize the values of the ECM. Okay, for example, with the given ECM equal to 2.4, first step we have to look for the closest quantization level, which is 2.5 volts, and this is, we take this one, map to the table. Okay, now what 2.5? 2.5 volts. We take the natural binary code is 0, 1, 0, 0. Okay, and what about the code for offset? Offset 2.5 is in here. We look at on the left-hand side. Here is the offset binary code, 1100. Okay, and the right-hand side is 0100 is two complement codes. We can look at the most right-hand side column to work out for two complement codes, or we just take the complement to the MSB of the offset binary code. All right, okay? It's okay to everyone? No problem? Okay, I checked it. Okay. Assume, yeah? Assume we have three values of the ECM. 1.76 minus 0.75 and 0.85. So try to find out the natural offset and choose complement. Okay, practice. Okay, try to convert it. I will ask you about the results of the course. For a given cost table. This is namely the cost table. We apply for a case of R equal to 10 and B equal to 4. For bits, 10 volts. Okay? But bear in your mind when I change the value of B and R, so you have to rebuild the cost table. Fit to the new ones. Okay? This one just the cost table. This is the example. Apply to the case of R equal to 10 and B equal to 4. Now assume this one we apply to this case. Turn on the camera, all of you. Turn on the camera, all of you. Okay, I check your attendance. Nguyễn Vĩnh Hảo, where's Nguyễn Kim?
I'm here.
Okay, Nguyễn Kim. Trần Lê Trung.
I'm here, sir.
Okay. Quỳnh Ngọc Tâm. Where's Quỳnh Ngọc Tâm? Tâm option. Lê Minh Tiến. Okay. Nguyễn Thiếu.
Dạ em thầy ơi.
Okay. Trà Quốc Khang. Khang option. Đặng Đức Toàn. Where is Đặng Đức Toàn? Where is Trà Quốc Khang? Khang. Where are you, Khang? I see your name in the list. Where are you, Khang? Trà Quốc Khang. Okay, so I know. With the online, some students, they logging into the meetings and do something else. So, Trà Quốc Khang, yeah, I put your option, yeah, Khang. Wait. Where are you, Đặng Đức Toàn?
Yes, it's me.
Turn on the camera.
Just wait a little. I will turn on my camera.
Turn on the camera. I'd like to ask you about this tutorial. Yeah, we can say this one is a minor tutorial. Just checking your understandings about how we can Okay. Now, did you work out the values of? Vâng. Vâng. Bất trà quốc khang still. Vâng. Now, what's the SQ of 176? Hmm? What's the value of SQ for 1.76? Can you see the board clearly? Okay. Just if you want to see the board clearly, you just into my picture, and then you can see the board instead of the slide. Okay. Now 176. What the value is Q? What the corresponding is Q? Okay, I check with another one. Huh? Trần Lê Trung.
Yes.
Okay. Now, what 1.76? What the value is Q?
I can't see clearly, sir.
Just pin to my photo. Pin to my photo. Pin to my photo. Ghim vào cái hình mà có thầy đó.
Yeah.
Ok, đó. Thì chúng ta sẽ thấy, ok, 1.56. What the value should be. Nhìn cái bảng đó, chúng ta nhìn cái cost table đó. Nhìn cái cost table đó, not through the cost table. Okay, then you can work out for the appropriate quantization level. What the SQ of 176 should be? Hurry up, Trung. Okay, Kim. What the value of SQ of 176?
1.1.
No.
It's not 1.1.
No. Cannot be 1.1. Okay. Now, Lemon Tiến.
Here.
Okay.
0.6. 35.
Why 0.6? No. Trà Quốc Khang. Are you there, Khang? No. Khánh, Nguyễn Ngọc Khánh.
Yes, I'm here.
1.76. And then the SQ would be
1.875.
Yeah, 1.875. The next. What the next?
Minus 0.75 is minus 1.25. Oh no.
No.
I think minus 0.625.
Yeah, 0.675.
0.85 is 1.25.
1.25.
Yeah.
What the quantization error in this case?
0.625. Teacher.
Yeah, should be 0.625.
Yeah.
625. Now, bear in your mind when we want to round up or down, the value of each end become to be shift to the quantization level. Okay, we have to look for the closest one, the closest value of each Q, each end to each Q. So that means in the case if your answer is this one, yeah, is 125. That one is the quantization error higher than half Q. What is the half Q in this case, Hill? Half Q, the maximum quantization error.
10, teacher.
No,
SQ.
half Q. Specify for maximum, the maximum of quantization error. What is your answer, Khan? What is the value of Q? What the value of Q?
Value.
What the value of Q? Q in this case equal to? What the value of Q, Hill?
I think
Mm,
8.75.
no.
No.
What the value of quantization resolution? Yeah, 0.625. Okay. So half Q is 0.3125. Okay. So the difference between this and is Q should be less than 0.3125. Okay. So, or we just look at the closest value of the SQ in the cost table. Okay, 0.85. This is the closest one because the error just to 0.225. It's okay, less than 0.325. Similar to this, similar to this. Okay. Right? It's okay, Trung?
Yeah, it's okay now, sir.
Okay. Can you work out for the natural cost? For this one, Trung? Just map to the cost table, and then you can abstract the corresponding cost. Look up table. 1.875. Just look at it. 1.875. Go to the left hand side. You can work out 0011. Okay. How about the offset binary course, Khánh?
It's 0011.
No. Offset course. The offset course of this one.
Binary.
1.875. What the offset course of this one? Nguyễn Vĩnh Hảo. 1011, because 1.875. Yeah, go to the left hand side, we have 1011.
I think it's two
Complement. To complement. Vĩnh Hảo. 0011. That's the complement of the MSB. It's okay, Trung? Okay. What's the natural cause? Hiếu? What's the natural cause of this one?
1111.
No. Kim. Where's the Kim? Nguyễn Kim.
Here, sir.
Okay. What's the natural cause of this one?
It's 0001.
No. This is because this one is a negative value. So not apply to the case of natural cause. So we should better put NA. What the NA is specified for, Han?
Yes.
What the NA? NA is specified for?
No answer.
No answer. No.
No.
When you fill up the form, when you make a visa form, for example, yeah, the embassies or the consulates general would ask you many questions. But some questions, if you don't want to put any information related to the question, you can put NA. Not applicable or non-applicable. Tức là không có áp dụng ở trong cái trường hợp này. Chứ không phải là no answer nhé. Không phải no answer.
Yes, sir.
Non-applicable hay là not applicable. Đó. Tức là cái cột này tôi không có áp dụng. Ví dụ cái cột, ví dụ hỏi là how many children do you have? Okay, in your case, you are not married, so you can put that NA. You do not have any children, so you put NA in there because you are single. So no children can be applied to. Okay? So now, Hill, what the offset scores?
111.
No.
The offset.
Kim, what's the offset cost of this one?
I think it's not available.
Now, offset and choose complement, they are bipolar
Oh.
codes. So that means, yeah, they can convert the negative and positive value of SQ. Okay? Just the case of the natural, because the natural course is unipolar course. So we do not apply to the negative value. How? What the offset cost of this one? Okay, 0.111. Okay, so you see this one. This is minus 0.625. We go to the left-hand side. We can see 0.111. Okay. Then you can look for the most right-hand side. You can work out for the two complement code 1111. Or you can check the complement of the most significant bit in the offset binary. Okay, Kim? Are you understanding?
Yes.
Okay, how about this?
I think it's 0.101.
Now, natural. What's the natural code? Toàn, where is Toàn? Toàn. Toàn. Where are you, Toàn?
Yes.
What's the natural code?
Um, it 1010.
How?
It what?
Lấy mình tiếng.
Oh.
0001.
It 00.
0001.
Yeah.
Next, lấy mình tiếng.
1001.
1001. Okay. When you have the offset cost, directly you can work out for two complement by checking complements of the most significant bits. It's okay, Kim?
I think I need more time to understand this.
How about you, Tuan?
Just
Are you
now
understand?
I know. Yeah.
It's okay or not?
It okay.
It's okay?
Yes, it okay.
So, again, for a given event, the first step you have to work out for the SQ. Okay, round up or down the value of event, switch to the quantization level. After this step, when you get SQ, just map into the code table. Map into the code table. Then you just look up table to work out for. For example, 1A75. Okay? Here we have 1.A75. Go to the left hand side, you can see the cost is 0011. Okay, with the offset binary, yeah, we have a 1.75. So go to the left, we get 1011. And go to the right hand side, we can get 0011. Or just based on the offset code, complements of the MSB, right? And then straightforward, you can write down the choose complement. Otherwise, you can look at the most right-hand side column to work out for choose complement. Now, what about the negative value? Because we know the negative value not be applied to the natural cost. Okay, the natural cost cannot convert the negative value. Okay, so you can put the NA non-applicable or not applicable. But the offset and choose complement, yes. Okay, minus 0.625. Okay, we get 0.111. And in the case of choose complement, just check complements of the MSB of the offset code. Okay, no problem. Okay. And this one just show you that is the block diagrams of a system, how the circuits, yeah, for an ADC conversion. Okay, this is the block diagram that is, yeah, the IC circuit would based on for ADC conversion. Okay, this one actually, yeah, you learn in digital circuits or electronic circuits. Okay, I'll let you take a few minutes to recognize the significant information in this example. Try to recognize by yourself rather than I just explain a bit to you. Huh? Okay, try to think over and recognize why we get is N and then is Q and then choose complement offset code. This would be better, yeah, for you to understand. It's okay, everyone? This one, yeah, that is a sinusoid. A is equal to 3 volts. Okay, 3 volts. And this one, F equal to this one, 0.04 cycle per sample. Corresponding how many hertz? How many hertz? Zero point zero 0.04 cycle per sample. Okay. You can work out for the corresponding f, and then you find out the first 10 values of n. Okay? So the first 10 values. The first 10 values. And we take the SQ, the corresponding to quantization level. And then we still use the 4 bits ADC, R equal to 10 volts. Okay? Then we can work out for, when you know the SQ, just map to the course table, lookup table, and then you can work out for choose complement. And bear in your mind, yeah, the negative value cannot be applied to the natural binary course. Yeah? Okay. Now this one, the detail, just quickly pass through. Yeah? Actually, this one, the dista is a low-level white noise. Add to the input before quantization for eliminating granulation or quantization distortion. So because when we do for ADC conversion, in the case of the signal with low level, then the ADC conversion will route it up or down. So that also means many low-level samples would take the same value. So that one may cause that one is, we say, quantization distortion, or the distortion caused by the quantization. To overcome that way, the techniques, namely the jitter, use the jitter add to the low level, add to the signal. Okay, we see. We have analog and digital jitter. This is the case of analog. This is the analog, ST. It is a jitter generator. Add to the ST, and then put to the ADC converter. And this is the digital, okay, or discrete times jitter. We have a discrete time signal add to the VN, discrete noise add to the SN, and then put to the quantizer and do for ADC conversion. Then we can write down Sn equal to Sn plus Vn. Okay, and the quantization error will be En equal to this. Okay, and the total error resulting from jitter and quantization, we get this one. Okay, we work out for total error noise power equal to this. It is the noise power in the case of the normal one when we do for quantization. This is because we add jitter to the signal as well, and it is a noise. So we take into account for a noise of the jitter, noise power of jitter. Okay, and this is the two common rectangular and triangular jitter probability density, rectangular and triangular. Okay, and this is the results come out, the total error, noise power, no jitter, with rectangular jitter, with triangular jitter, and this is with Gaussian jitter. Okay, and this is the block diagrams of the ways to apply the jitter. Sn add to the jitter and go to the quantizer and digital channel or do something for signal processing, and then after that, yeah, we can deduct it from the data again. We can reconstruct the wirehouse. When we look at this one, yeah, this is just a sample. We see this is undeterred quantization. Okay, this is sideways, and this is a quantization level. We see the spectrum, the case of undeterred spectrum, except the main spectrum. We still have that is multiple harmonics in here with a high level. But when we apply the deter, okay, then we can get the main spectrum and the harmonics are higher frequency. They are unwanted, unwanted spectrum. Okay, seems to be lower down very much. So that's this one, yeah, would make the quantization step become to be better than before. Huh? Okay. Okay, now we finish the chapter 3. Do you have any questions? In Vietnamese, we just, that is a specific name. So we would not translate directly the values of ether into Vietnamese. So just say ether đó là một cái nhiễu thôi, một cái nhiễu trắng. Nó là một cái nhiễu trắng. Cái nhiễu trắng về sau chúng ta học trong communication hoặc là nhiều cái course khác nhau, chúng ta sẽ nghe cái từ nhiễu trắng. Nhiễu trắng là nó có cái phân bố, cái hàm mật độ phân bố nó phẳng trên toàn cái tầm tần số. Thì chúng ta gọi cái differ thực ra nó là một cái nhiễu trắng, có biên độ bé đó chứ thôi. Differ như vậy. Đấy, nói dông dài như vậy. Đúng cái định nghĩa của nó là một cái specific name, nên là chúng ta không có directly mà translated into Vietnamese. Just explains about what the names of differ. Okay, the differ is the low level white noise. Đó là một cái nhiễu trắng có mức thấp. Okay, any more questions? No question? Okay, we take a short break. Yeah, we take a short break. It's about 10 minutes, and then prepare for chapter 4. Okay, and then we come to chapter 4. Chapter 4 we can run quickly because I believe most of the background you already get. Okay, take a break and try to download the tutorial number 4. Tutorial number 4. Yeah? Okay. We would practice on tutorial number Okay, where are you, Vic? Vic? Turn on the camera, Vic. Vic. Đặng Văn Vic. Vice monitor?
I'm here, sir.
Okay, turn on the camera.
Yeah.
Thanh. Bác Thanh.
I'm here, sir.
Okay. Did you fix your camera?
Not yet, sir.
Okay, next week, yeah?
Yes.
Next week, I expect to get your photo, your picture, okay? And want to see your face as well. Okay. Now, chapter 4. Chapter 4, actually, this one, I believe that you have some background related to this chapter. Because chapter 2, after chapter 3, we did talk about, that is the thing. And from chapter 4 to the end of the course, mostly we deal with the discrete time signal and discrete time system. Okay, from now to the end of the course, most of the concepts will be related to the discrete time signal. And this is the basic one. So I believe you already learned in the course signal system and variety of course. So I just pass quickly, just remind you some significant concept or new, maybe the new to someone. Now look at this one. We say a bit about I/O input output rules. Or also that one is the relationship between the input and output signal. And you know about what the basic about the times and linear and times invariance. Okay, in here I just remind you again how we can check the linear and times invariance properties of the system. Okay, for a given system. For a given system, we know about the I/O relation. We know already in the I/O rules. And then how we can check the linearity and times invariance properties of the system to make the conclusion whether the system is linear or not, or times invariance or times variance. Times invariance, in short, we just say TI. Times variance is TV, okay? So from now, sometimes when I say TI or TV, you would recognize what I mean for. And remind you again about the impulse response, and that is the what we define for a finite impulse response, FIR, or infinite impulse response, IIR system. Okay, a bit very much easy to recognize in the case of finite impulse response. That means that the length of the impulse response is limited. Whereas the case of infinite impulse response, that means the length of the impulse response is infinite. That's easy one. Have you ever heard about the FIR and IIR? Haven't you ever heard about the fear and the ear? Yeah, we say in Vietnamese. Fear and ear. Have you ever seen or hear or knows about FIR and IIR system? What is your answer, Viet? Can you
Yes,
hear
sir.
me?
Can you repeat the question?
What a problem with your speaker?
It's quite noisy here, so I can hear you clearly.
Okay. So you can, yeah, you can turn up the volumes of the speaker. Yeah. Okay. Now the question: have you ever hear or knows about the FIR and IIR system? Just say yes or no.
No, sir.
No?
No,
When you
sir.
learn in signal system, you did not know about the FIR and IIR
Yeah,
systems. Hmm?
yeah. I didn't know about it.
Okay, okay. So, remind you again, very much easy to remember. FIR system is the system with the impulse response has a limited number of samples, or the length of the impulse response is limited. Cái chiều dài của cái vector impulse response nó sẽ hữu hạn. Whereas infinite impulse response one just related to the past and present sample. Okay, if you recognize, so yeah, we can apply to the tutorial number 4. Yeah, I did upload to the e-learning. Okay, we can practice. No problem. This one we pass through, except this one just define for what the passive and active system. Passive system, the output energies of the output smaller than the energies of the input, and the lossless system when the energies of the output equal to energies of the input, and the active system if energies of the output greater than energies of the input. That's all. Okay, so just the terminology. And CP system, DT system, no problem. Digital system, okay, no problem. Analysis and design, we split up into analysis and synthesis. Okay, now if we want to do the design by analysis, yeah, we can use an existing system and we try to modify the characteristic of that existing system. Okay, for example, if you want to design a new circuit to do some specific task, yeah, you can take a sample of the circuit. Okay, and then you try to modify something, the circuit, to fit to the specifications of the task. Okay, that way, yeah, we say we design the circuit by analysis. What about the synthesis? Synthesis, we define the form of systems directly from its specification. We base on the specification of the task, then we use that one to put them up and find out for a suitable way, yeah, fit to the specification and merge them up, become totally that is the circuit for designing. That way we say we design by synthesis, tổng hợp, phân tích và tổng hợp. Tổng hợp từ những cái thông số specification, thông số của một cái công việc đó hay là cái mạch đó. chúng ta thiết kế lắp ghép nó lại. Còn nếu mà chúng ta muốn thiết kế theo cái dạng analysis thì chúng ta cứ lấy một cái mẫu, một cái hệ thống đã có sẵn, xong rồi chúng ta tìm cách chúng ta pha chế cái thông số, pha chế cái mạch này để cho nó thỏa mãn. Ví dụ chúng ta muốn thiết kế một cái bo nguồn cấp điện 5V, chúng ta có thể tìm ở trong cái handbook có một cái mạch có sẵn 5V đó rồi. Rồi chúng ta mới đi, chúng ta tìm cách thay đổi điện trở, trụ điện cái gì đó để cho nó thích ứng với lại cái thông số mà chúng ta muốn thực hiện. Xong thì còn trong cái synthesis thì chúng ta phải dựa vào trong cái thông số 5V dòng bao nhiêu thì chúng ta phải đi từng bước chúng ta mới thiết kế những cái tìm ra những cái form nó thích ứng với lại cái điều kiện đó, rồi chúng ta lắp ghép nó lại để hình thành cái design. Okay, block diagram. So block diagram, all of you would know. I just show you that is the basic elements of block diagram. We have delays block. Delays block. Did you learn about the Z transform? Did you learn
Yes.
about the Z transform? Did you? Yes or no?
Can you repeat? I can hear you.
Well, you asked me to repeat many times. Huh? Okay. How did you learn about the Z transform? Okay. Yeah, that's one. Yeah. Okay, that also means my voice is normal. Yeah, good for the other student. So you have to check the loudspeaker. Yeah, with. Okay, enough. Yeah, the problem because the noise in the background. Okay, that is a delay block. When we put Z power of -1, that means the output is the input delay 1 sample. When we put inside Z power of -3, that means the output is the input delay 3 samples. Okay. So this one we say the delay block, and this one we say the gain or amplifier. Gain or amplifier, no problem. And differentiator or differentiation. Okay, anyway. Okay. And we also may get some point, multiple input, one output. Take-off point, one input, multiple outputs. So we can connect the block diagram in cascade form, dạng nối tiếp, or in feedback form, dạng hồi tiếp, or in parallel form, dạng song song. Okay. Stage. For some system, the output at time t0 depends not only the input but also the previous one. Okay. The stage information define this one. When you learn in digital technique, I believe that you would very much often hear about the stage. And the dynamic equation is setup equation describes the unique relation between input, output, and stage. Okay, the stage. That means not depends on the current input, but also the previous or the stage. So that one, dynamic equation. What the relaxed system? Okay, very much simple relaxed system. Okay, at the time t0, if the output solely determined by the input for t greater or equal to t0, relax. In terms of energy, no energy stored in the system at t0. This concept, Normally, we apply to the case of capacitor and inductor. When we do the circuit analysis, okay, we have an initial condition where the capacitor or inductor store some energy before the starting, okay, before T0, okay. So linear time, LTI, I believe, yeah, you hear the LTI terminology very much often in variety of courses. Okay. In Vietnamese, we just say tuyến tính, cái tính chất tuyến tính và bất biến theo thời gian. But in Vietnamese, yeah, we rarely use the passive voice. So we just say bất biến thời gian. Tuyến tính bất biến thời gian. Actually, bất biến theo thời gian. Khi mà thời gian thay đổi thì cái tính chất nó có thay đổi như vậy. Nhưng mà chúng ta tiếng Việt chúng ta ít có dùng cái thể passive, bị nghe nó nặng nề lắm. Chúng ta có thể nói nhanh là tuyến tính bất biến thời gian. Yeah. Okay. And the LTI system separates into the finite simple response and infinite simple response. Finite but infinite. Yeah. Okay. Not infinite. Yeah. Infinite. Remember the pronunciations. Okay. Finite simple response and infinite simple response. So I will let you know already. So what about the finite impulse response? Okay, that means the impulse response has a limited number of samples, whereas the infinite impulse response has an infinite number of samples, or the length of the impulse response in fear is limited, but the length of ear system is unlimited. This one, no problem. When we represent signal in terms of impulses, I'll let you take a few minutes, yeah, to recognize this is a review one. Right? Now, what the basic definitions of the impulse response? I forgot to remind you about. That is very much important about the basic definitions of the impulse response. Button. What the basic definitions of the impulse response of the system? And maybe the monitor he is sleeping, huh? Where are you, Button?
I'm here, sir.
Okay. Why? You did not respond to my answer, my questions.
Because I cannot hear your voice clearly, sir.
What a problem.
Because I cannot hear clearly the word you say.
You know what a problem? Because the speaker or because the internet links or
I think that's is because of my internet, sir.
okay. So and now my question is, what is the basic definitions of impulse response? Can you hear the questions?
Yes, sir.
Okay. Now next time, yeah. Next time I want to see your face. Okay. Because face to face, yeah, sometimes you can guess Yeah, the voice is even. You would not hear clearly. Okay. Okay, button. Now, what the basic definitions of the impulse response of a system?
Uh,
Okay. Now, Kim, I checked the communications
I'm here, sir.
as well. Kim,
I'm here, sir.
okay, turn on the camera.
Yes.
Now, because we have a small number of students, so
Okay.
try to turn on the camera. Okay,
Okay, I got it.
okay. So, you know the basic definitions of the impulse response?
Uh, I think it's
Okay,
I
okay.
think it's equal to 1 when n equal to 0 and
Han, are you talking?
yes,
Are you speaking?
yes, sir.
Okay, okay.
Do you hear my voice clearly?
Sure. Now, say again.
I
Say
think
again.
that the definition of impulse function is that it's equal to 1 when n is equal to 0 and in other case it will equal to 0.
Now, impulse response. Basic definition of the impulse response, not the definitions of the impulse. The definition of impulse response. Đáp ứng xung nha.
Yes, sir.
Okay. Say again, Thanh.
I think that
Okay, okay. I move to another one. Okay. Trung, Trần Lê Trung. Trung.
Yeah.
Okay. Now, you know about the basic definition because this one is very much important. If you know the basic definition later on, yeah, you can very much easy apply to the tutorial, yeah, to work out for.
Um, cái này em nói tiếng Việt được không thầy?
Yeah, okay, okay, no problem.
Em nghĩ là cái đáp ứng xung là là một cái quá trình đó thầy. Quá trình mà sau khi mà được tác động bởi một cái xung á thì
No, okay. Now, Cha Quốc Khang, where are you, Khang? Cha Quốc Khang.
I'm here.
Oh, where were you?
I'm go out to test
Turn on
COVID.
the camera. Turn on the camera.
I'm just use my phone, so I can turn on my camera.
When did you join to the meeting? When?
Yeah, sorry.
Khang,
I'm here.
vào lớp lúc nào vậy? Hả? Sao thầy lúc đầu buổi thầy gọi hoài không thấy? Hả?
Em đi ra ngoài để test COVID cho thầy, cho nên em có
Okay, I understand. That's COVID. Bây giờ mà còn test hả?
dạ vâng còn test.
Okay, so I understand. Okay, so. Okay, you know about the basic definitions of the impulse response of a system? Hả? Okay. Now remember, by definition, impulse response of the system is the output when the input is a delta function, or when the input is the impulse function. Okay? Impulse function or delta function, which is the output of the system. And we know the delta t, ht, corresponding to the case of continuous time system, signal system. We use the delta n, hn, applied to the case of, we deal with the discrete time system. And we know the delta t or delta n, they are ideal signal, not the practical one. Then the ht and hn is also ideal, not the practical one, but the people still use to explain furthermore about the behavior of the system. And in the case of arbitrary input signal, namely ht or hn, then we take the ht or hn specified for the response of the system to the input signal. Then we get yt or yn. And we know yt equal to ht convolves ht, and the yn equal to Sn convolves Hn. Okay? Now, try to remember, because that one would help you a lot about when you work out for the answer or the solutions of tutorials. And it is the basic ones throughout the system, signal system, or DSP, or communications, or any cases when we deal with the signal system. Okay? Remember? Okay. So, turn on the camera, Kang, because you use a mobile phone. So, mobile phone easy to turn on the camera. Okay. So, what kind of vaccines you got? Oh, you do for the test? You do just do for the test. Okay. How many injections you got already?
Sorry, and what do you?
How many injections you got already? Tiêm mấy mũi rồi?
Just one.
One. What kind of vaccine?
AstraZeneca.
AstraZeneca. How about you, Vatan?
So I'm his. I have one, just one.
Astra.
Astra, yes.
AstraZeneca. Any of you got Verocell? Any of you? No answer. Okay. So remember, yeah? It's okay? All right. I will practice you later on. So this one, make sure you understand this case. Now, input-output rule, very much easy. Yeah, we have a sample-to-sample processing or block processing. Easy to understand. Huh? Each input sample, system responds to each input sample. Then we would say, yeah, we do for sample-to-sample processing, sample-to-sample or sample by sample. But in the case if the number of input samples are collected in blocks, and then the system responds to each blocks every time, then we say the system use block processing methods. sample. Okay. Now, linearity, all of you would know. I just let you know the ways how we can test or how we can check the linearity properties of a system. Okay, if we want to check a system is linear or not, we can use two models. Okay, two models. The first model, assume we have a two input signal, is one and is n, is one and is two. Now the first model, we check the linear combination first, and then pass the signal through the system. This is specified for the system. We have an output 1. The second model, we pass two signals through the system first, then check the linear combination. We have an output 2. We compare the output 1 and output 2. If they are equal, then the system is linear. Otherwise, non-linear. Okay? Right? Two models. Okay. Yeah, we will practice later on. Now, the times variant, you know the basic definitions about the times invariant already. So I just show you the way how we can check the times invariance properties of a system for a given I/O equations. Okay, that one specified for the relationship between the input and the output. How we can check the TI properties of the system. Okay, we use also two models. The first model, we pass the signal through the system first and then delay. We have output 1. The second model, we pass the system through the delay first and then through the system. We have output 2. Okay, again, we compare the output 1 and output 2. If they are equal, then we make the conclusion the system is TI, otherwise TV. Okay? It's okay, Kim?
Yes, it's okay, teacher.
Okay. How about you, Quốc Khang?
Yeah.
Quốc Khang?
Yeah.
Okay. No problem?
Yeah.
Okay. Nguyễn Ngọc Khánh?
Yes. No
Turn on
problem.
the camera. Turn on the camera, Khánh.
Oh, yeah, I'm here.
Okay. Now, where is Quỳnh Ngọc Trâm? Quỳnh Ngọc Trâm. He absent last week as well. Trâm still absent, yeah? Here, Trâm, Trung, here. Okay, so we stop the lecture today. Now, any question you want to ask me for?
When we have midterm test, teacher.
Say again, Khang?
When we have the midterm test.
Oh, wisdom test is, yeah, it still take a long time. Yeah, I think, yeah, we still have some more weeks today to go, yeah? Some more weeks to go. About 3 or 4 weeks, I think.
Thank you, sir.
Okay. And maybe, yeah, maybe I may apply that is the minor midterm exams if available. Minor midterm exam. to practice you on. Haven't you got the tutorial number 4, Viet? Tutorial number 4, 4B? Tutorial? No answer. Okay.
Yes, I can find it in my big scale.
Okay. Han, did the TA contact you?
No, sir, I didn't find.
Okay.
I will check my mail again, but
Okay. I passed your telephone and email to the TA.
Yes.
He will